This poster talk is about delta-8 tetrahydrocannabinol, a less common cannabinoid with a challenging detection. Delta-9 tetrahydrocannabinol is the best known and most active cannabinoid in hemp cannabis sativa. The plant material contains beside delta-9 tetrahydrocannabinol a great number of other natural cannabinoids, for example cannabinol, cannabigerol, cannabigerine. One of the minor cannabinoids is delta-H tetrahydrocannabinol, which differ only in the position of the double bond compared to delta-9 THC. The reported Ke values for the CB1 and CB2 receptor are slightly higher compared to delta-9 THC. Therefore, a similar action with a less potency can be expected. A study after controlled oral and intravenous administration confirmed this assumption. The relative potency was estimated to 2/3 compared to delta-9 THC. Lately, more and more products advertised to contain delta-8 tetrahydrocannabinol occur on the market and in web shops. One reason for this increasing occurrence can be the unclear legal status in a variety of countries. According to WADA Prohibited List Δ8-THC is to be regarded as prohibited substances under Section S8, Cannabinoids, Natural Synthetic Tetrahydrocannabinols. In contrast to delta-9 THC, a regulation concerning a threshold concentration is not given for delta-H THC. Information concerning metabolism of delta-H THC are limited to a few publications. According to this literature and based on a structural comparison, the metabolism of delta-H THC is comparable to delta-9 THC. Main metabolite is the carboxylic acid in both cases. The starting point for the identification of delta-H THC is a real urine sample. The use of cannabidiol oil is declared for the sample. In the routine screening procedure, the sample is hydrolyzed enzymatically by using glucuronidase from E. coli. After hydrolysis and adjustment to pH 9 to 10, the sample is extracted with TBME. The organic layer is evaporated to dryness. After derivatization, the analytes are measured by GC-MS-MS as TMS derivatives. In the case that the concentration of delta-9 tetrahydrocannabinol exceeds the laboratory internal cutoff, quantification using LC-MS-MS is performed to determine if the concentration is above the threshold concentration available in the technical documents of WADA. Since it is known that enzymatic hydrolysis using glucuronidase is not complete for quantification, an alkaline hydrolysis using potassium hydroxide solution is performed. After alkaline hydrolysis, the sample is extracted using cyclohexane ethyl acetate. The organic layer is separated and evaporated to dryness. After reconstitution with a mobile phase, the sample is measured using HPLC-MS using a gradient elution on a C8 stationary phase. On this slide, the results of the routine testing procedure are presented. The screening using GC-MS results in a finding of delta-9 THC carboxylic acid above the laboratory internal cutoff. A second peak is visible in the GC-MS chromatogram, which was afterwards assigned as delta-8 THC carboxylic acid. The quantification by LC-MS resulted in one peak, a co-elution of delta-8 and delta-9 THC carboxylic acid. Because of relevant differences in the concentration of delta-9 THC carboxylic acid between screening and quantitation, and slightly differences in chromatography, which can be seen here, a follow-up testing procedure was performed. Therefore, an HPLC-MS analysis using an Isocratical elution on a C18 column was performed. This analysis results in two peaks. One could be assigned as Δ8-THC carboxylic acid and the other one as Δ9-THC carboxylic acid, compared to certified reference material. The fragmentation pattern of both substances is the same, as you can see here. The concentration of Δ8-THC carboxylic acid was estimated to 500 nanograms per ml, and the concentration of Δ9-THC carboxylic acid to 100 nanograms per ml. A follow-up testing procedure using GC-MS-MS was also performed. Differences between Δ8 and Δ9-THC carboxylic acid as bis TMS derivatives are visible in chromatography and especially in fragmentation. In conclusion, of particular importance is the fact that for an unambiguous identification and quantitation using HPLC-MS, an isocratic elution is essential to avoid a possible false positive result for Δ9-THC carboxylic acid. In this specific case, the concentration of Δ9-THC carboxylic acid was estimated in the normally used routine quantitation method higher than the decision limit. In reality, and using the follow-up testing procedure, concentration of Δ9-THC carboxylic acid is below the decision limit. A co-elution of Δ8-THC carboxylic acid is responsible for this overestimation. In addition, it should be mentioned that WADA documents should pay attention to the possible increased occurrence of Δ8-THC in the near future. Thanks for your attention.